This is another example of an SN1 reaction. This is number 5 from the synthetically useful substitution and elimination reactions. This one is called solvolysis, and that's because it's the solvent, here water, and the solvent is lysing or breaking apart. And what we're going to do is it's going to be a substitution reaction where we're actually going to take an alkyl halide and turn it into an alcohol. You could also do this with using alcohol as the solvent. If you were to take alcohol as the solvent, then you would be producing an ether as the product instead of an alcohol. Okay, so here the specific example that we have this secondary alkyl halide, which if we have a secondary substrate, we might be thinking to ourselves that it would be likely to be SN2. However, with water as our only solvent and reagent, so sometimes things are the solvent and a reagent, this is going to be a weak nucleophile / base. No temperature is indicated, so the assumption here is that it must be around or near room temperature. So since we have a secondary substrate, a weak nucleophile / base, and lower temperatures, this is going to go SN1. Okay, so the first step in an SN1 mechanism is, of course, heterolysis. And here we have a great leaving group already. So we don't have to do any work to get that converted into a good leaving group. So we're just going to go ahead and do our heterolysis. Okay, as always, that gives us a carbocation intermediate, trigonal planar, geometry sp2 hybridized, and then we have our chloride here. Now, it is entirely possible that the chloride anion could go back and attack. However, the assumption here is that with the solvent being water, we have a lot more water molecules present than we do chloride ions. So what's going to happen is the water is going to attack the carbocation. Now here we have a secondary carbocation, and if we try to rearrange, we just end up with another secondary carbocation or a primary carbocation. So here there's no advantage or reason to do that rearrangement. So we'll go ahead and do our coordination step, which here our nucleophile is going to be water. As always with SN1, we can attack from the front or from the back. So, or top or bottom or right or left or however you want to think about it. So what I like to do is just draw one of the enantiomers and then say plus En. But if it makes you feel better, feel free to draw this exact same molecule that I drew, but with the protonated alcohol on the hashed wedge and the hydrogen on the bolded wedge. All right, we're almost there. All we need to do now is to deprotonate that alcohol. Now, we don't have any great bases present, so we're going to have to just use water as our base. So this would be a reaction that might be helped along by some sort of acid or base catalyst. So this will be proton transfer. And mainly we're going to have proton transfers like this when we have a neutral nucleophile like we have here. Okay, so we end up with that plus the enantiomer. Again, because it's SN1, a racemic mixture. Again, if you want to draw out both of the reactions, both of the products, you're welcome to do so. And then here, the byproduct, of course, would be hydronium cation because the water acted as a base and took that proton. So now this one could end up being a little more complicated if there were a rearrangement. but in this particular case, there was not.